Hello, this is Chaos Nature here. Here to present my solar setup to you. This is project today is solar setup. I had just done a 30 minutes video, which I realized that the mic was off after talking to myself for half an hour. So I'm just gonna go through it again, and hopefully I'm able to cover what I covered before. Basically, I have a setup today, which is a Solis setup, I call it. So the Solis is connected to two batteries, which I have connected in parallel. And my parallel connection, if I can see if I can get, see if I can, give me a second. So this is currently my setup, and as you can see, I've got one string of wires coming here. If you can see, let me zoom in if I can zoom in. So one string of wire coming like that, and it's going to the inverter. That's the negative, and then the positive going to the inverter. So I've got two bus bar, one bus bar here, one bus bar there. So all the negative of the two batteries go there. So battery 1 goes there, battery 2 goes there, battery 1 positive go there, battery 2 positive goes there. This plug that you see here is a cable that I use to power my ESP32 chip, which is here. I'll talk about that in a minute. This is the switch for the solar that's coming in, and it comes here, and there's a switch, and this solar goes all the way to the inverter, and then the inverter is plugged into one of these plug here. I think it's this plug here. So this is where the current goes in and out of the grid. So we're far away from the meter, and that's what you can see there is the data logger, which allows you to read the data from the inverter. So that's basically the setup that I have, and the ESP, what is I will talk about this in a minute. This is the card that I make in Homeassistant, that allows you to monitor the two batteries. So that's the master and the I'll show you, and I'll talk about that in a minute. Let's not diverge here. So basically, that's where we're at today, where we came from. So I started with this setup. So I had a Vevo controller and a Sun inverter. This is a 2000 watts inverter. So I had the Sun inverter and a Vevo controller, and this controller was charging. So this is a controller charges a battery. So that's what it does. It controls the current and the voltage that goes in and out of the battery, and then this tells you what to decides what to do with whether to give it to the inverter or give it to the load or whatever. So basically, it was charging these batteries. So these batteries were connected in parallel. So this is a 48 volt system. So each of these batteries is 12 volts. So I decommissioned that system and I went to Growatt. So this is a 48 volts Growatt battery, and this is another controller, and the controller is SP2000, which charges this GBLI 500 L or something like that. So I converted, so there's a so this controller will charge this battery, and there's another inverter which is not in this picture, which takes the charges and the current from the solar panel and brings it to the controller, and the controller gives it to the battery, and from the battery we decide whether to go to the load or store it, and blah 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 and all that. So basically, this was my system. So I eventually had two of these. So I had two strings, one in the near the kitchen in my storage area, and another one somewhere else. So I have now decommissioned the one in the storage and put the Solis system that I showed you earlier, and that's where we're at. So this is the panels and how they set up on the roof, and I have currently I think it's 10 of these. So if we say each of these is 540 watts, 540 watts times 10, so means I have a just over 5 kilowatts system. So at a very very top maximum, it can deliver 5 kilowatts. So it's actually more than the inverter can demand. My inverter, my Solis inverter, currently today is a 3 kilowatts Solis inverter, which is string 1. The string 2, which is a sofa setup, is a 3.6 kilowatts, which I have not set up, which I have not put up yet. Basically, yeah, I'm still working on that string, but this string 1 is serving the purpose anyway. So what I've done is I have converted this battery, removed the original BMS that was inside that battery. I'll show you how the BMS looks. I hope you are seeing this. I've removed so I've removed the BMS that was inside that battery, and I've put another BMS in it. I will be revealing the name of the BMS to you in a second. So the BMS that I put in there is, so the BMS that came out of that, where is it? I just want to show you how it looks. So this is how the BMS looks. So I just snap the wires, basically snap, and unscrew these wires. I can show you a better picture. Unscrew the wires and reconnect it. Remove this BMS and replace it with a JKBMS. JKBMS that I used was a power JKBMS. I did not know it's a power JKBMS until after I got into the project and realized that, oh, they classify as a power JKBMS, not an inverter JKBMS, but we were still able to use it for the project. That's how the BMS look. So this BMS is a 2 amp. It's a 2 amp it has a 2 amp balancer, which means each of these pack here is a cell. Each of these cells, they are 3.4 volt or 3.5 volt. It can go up to a maximum of 5 volts. So the sock of each of these cells is 4.1 volts, and the 100% sock is 4.1 volts, and the 0% sock is, I think is, we can just do the calculation. So from the data sheet, the operating voltage is 56, between 47 and 57. So 47 is the low end. Divide that by 14. So that's the lower sock. So in the JKBMS settings, I'll put the 0% sock to be that. And I'm going into detail now, but I will do a separate video on setting up the JKBMS as requested, in the comments. And then the top end, the 100% sock would be 57 divided by 14. So that is what I've set. I have set it as 4.1. So I'm maxing it basically, but that's what you should set, on the 100% sock. Yeah. So I removed that BMS and I put the JKBMS. The reason for this is because the old BMS, my Solis inverter, would not talk to the battery. The Solis BMS is old, has an old technology, and the protocols that it supports doesn't include pylon text and stuff like that. And my inverter, my Solis inverter, has a protocol, pylon tech and AOBO and SMA and all those other battery technology protocols set up in there. So this BMS here understands most of those protocols. So with this BMS I was using pylon. I say was because I later changed it to SMA as the program evolved. I'm using pylon tech protocol 2.0 and pylon tech plus version. I don't want to bore you with the technical details at this point. Like I said, I'll do a separate video, to look into that. So basically what I had to do, if you look at my system, so the design my original design, if I can find it, my original design was supposed to be looking like this. Where is it? Like this. There you go. I saw it just now. This was my original design, right? So the current is supposed to flow between one battery to the other battery, and I did not know about the balance. What I did know about the active balancing, but I also wanted the battery to talk to each other. So I eventually did another drawing. Not sure where that drawing is now. A modified drawing, I think is let me not waste your time. I'll pause the video and look for the drawing. So this is the modified drawing. So basically what I did was, I have one battery here, one Growatt battery, the GBLI 500, is it 5001 I think of, yeah, 5001 as a module. So I opened up the Growatt battery, removed the, like I said before, the old BMS, and put the JKBMS. So I had JKBMS on one battery, another JKBMS on another battery, and initially I wanted to connect the RS485 ports to talk to each other. So the JKBMS will be talking to this JKBMS, telling this battery 1 what this battery 2 is doing and what it's not doing, so that they can work together. And then I wanted to use the CAN protocol of the JKBMS to go to the Solis and talk to the Solis. So what later happened, what I found out, was that the CAN protocol that comes with the power JKBMS is disabled. So I had to cancel that design. So now I'm no longer using the CAN protocol. Instead, I'm using the RS485 port going straight to the Solis, but after the conversion. So I converted this RS485 port to a CAN port, and I now have, after the conversion, I have CAN H, CAN L that can talk to the Solis inverter, and there's no communication, TX RX communication between these two batteries. So the hope was and still is, and is actually working, it's not hope anymore, is that current flows like water. So if this is more than this, it will flow to this side, or if this is more than this, it will flow to this side. And plus there's active balancers working on each of them, so that keeps them leveled up. So if I can show you what I was talking about in terms of like, so this is how I had to wire my cable. So I had to pick 4 and 5, coming from the inverter side, going to the battery. So 4 and 5 from the Solis inverter, one is TX, one is RX, going to the inverter. And I think what I should show you next, that's basically it in another diagram. So what I should show you next is the actual wiring in the how it was wired in the picture. I think, yeah, that's it there. Not quite. It's another more explanatory diagram somewhere. So while I was looking for that diagram, I came across the data sheet that I was talking about. So this is the data sheet. So this is what I used, to determine the settings, for the battery, BMS battery. As you can see, it's 95.4 AH, and as a 57 to 56 as so I used 56 as 57 as the 100% sock, and 46 as the 0% sock, basically. So I was still looking for, what was I looking for? Yeah, so I found that I have so many diagram screenshots and stuff. So basically, I just wanted to explain to you basically how I connected the communication aspect of this project. So this is the JKBMS. From the JKBMS, you will take from the RS485, which is labeled GPS, a TX and a RX connection to the ESP technology. And the ESP technology, you will see, I will show you a diagram of the pin in a minute. So the ESP technology would have GPIO 16, 17. So the TX and the RX will go to the 16 and the 17 of the ESP chip. On the other side, coming out from the other side, will be GPIO 23 and 22. TX and RX will be going to another module, which is a CAN converter. So this is what converts the RS485 signal to a CAN signal. And once this CAN signal is converted, then it can now talk to the inverter. So I used TJA 1050 chip. There's quite a few other chips out there. I think they all work, but be careful, they don't all work. Some of them are dodgy, so if it doesn't work, know that you got a dodgy one. So did not need to use to connect the ground cable or the 5-volt cable. Actually, sorry, I take that back. So yeah, I did connect the TX, the RX, the ground, and I think it's the 3-volt I connected, or 5-volt, I can't remember now. But yeah, so from coming out from the other side of the chip is the CAN H and the CAN L, which is now a converted signal and can now talk to the inverter. Therefore, the inverter can talk to the JKBMS, which is wired into the battery, which means you're talking to the battery. So inverter can talk to the JKBMS, it means you're talking to the battery, because JKBMS is basically the battery, because the battery and the JKBMS are integrated through the wires. There are other options where you can use. So basically, when you see the JKBMS diagram, it's a little bit confusing, in the sense that at first, after doing a lot of research, and the reason why I decided to draw my plan the way I drew my plan was that the CAN port. There's a diagram I'm looking for that I want to use to illustrate this so that you get the picture really well. The CAN port that is designated to do the CAN communication is actually disabled, you know, by JK, the JK guys. So they released it disabled basically, and you know, not many people know. When you look at it, unless you really, you know, unless you've gone into the project, basically you will not know that it's disabled. I don't know, it's not clear from here. I wanted to show you a clearer picture. Yeah, this one here. So if you remember the diagram that I showed you earlier, if this was the way it is, what I wanted to do was connect the RS485 of one JKBMS to another JKBMS, and then connect this CAN port straight to the inverter, the Solis inverter or any inverter. That's if the protocols are enabled on this CAN port, and if this CAN port is enabled in the first place, which I later find out this CAN port is disabled. So because this CAN port is disabled, this is basically just got a cross against it. Now we cannot use it, not for CAN, not for RS485. So we're left with this GPS port, which is basically a TTL port. The TTL port means we have ability to communicate via RxTX channel. So this RxTX channel is what is now connected to the CAN chip that I showed you earlier, that converts the RxTX to CAN H, CAN L. Rewind the video and, you know, watch it again if you don't understand what I'm saying, but it's straightforward. So yeah, so that's basically it. So because of that not enabled, that changed my design to having two RS485, no, just using one BMS to talk to the inverter, and relying on the principle of, you know, current flow like water, you know, to have plus the active balances, to have the battery talk to each other. And it works because, as you can see, if I can show you, I can show you a live preview of the system as it's working today. What is this doing here? Yeah, so basically you can see, so that's the master battery and that's the slave battery. I'm doing this remotely, by the way. I'm not I'm not at home right now. It's discharging. You can see it's discharging, which means there's no sun. I checked earlier, and yeah, there is no sun. It's raining actually. So so it's discharging. So as you can see, what I've done, I created this warrants a whole new video, a whole video as well, like dedicated video for Homeassistant. So I created a card. It's quite straightforward as well. It's simple. I created a card, you know, that allows me to monitor both battery by adding each of the sensor so I created a card for each, for voltage, for example, voltage for the battery 1, voltage for battery 2, enabling the Bluetooth connection. I didn't talk about this. There's quite a lot. Like there's two. Right. So we'll go back to this. Let me explain. I think it's a key that you get this. So this TX-RX connection between the JKBMS and the ESP32 chip, you can have a wired connection, or a wired connection, or a Bluetooth connection. So I actually chose to go with the Bluetooth option. So this ESP32 is connected to the JKBMS via Bluetooth. I think I had problems with the wire, so I just jumped the solution and went to using the Bluetooth. So there's different code for Bluetooth and different code for wired YAML code. And the YAML code in question here is so if you go into ESPHome, if it loads, it's loading. Patience. I'm not sure I need to be going into this detail, but yeah. So that's the YAML code for battery 2, and that's the YAML code for battery 1. If you do edit, this is the code. So these are the releases. So there's been so many releases and so many modifications to the code by the smart guys. All credit go to these guys, Mr. Pablo Slipper. UK007 was the original, one of the original guys, but he's selling his solution. So yeah, it does have open source, but is mostly selling. It doesn't support you in any way. I don't want to go into that, but the credits mostly go to these guys here. You can see the work that they've been doing. So this is the code. So what I wanted the reason why I went into this was, so when you are doing Bluetooth, there's GPIO 23 and 22 is what get used only. But if you was doing wire, yeah, so the communication would be over GPI 22 and 23, and also GPI 16 if I can remember correctly, and 17. Yeah, so I've got 0 and 1. You can also use TX pin 0 and 3, but I tried 16 and 17, didn't work, so I was trying 0 and 3, it didn't work as well. I've not tried it on this new code, maybe it works now, but I just became comfortable with the Bluetooth solution, so I stuck with the Bluetooth solution. So basically that's it. So you can have Bluetooth or you can have wired between the ESP and JKBMS. It doesn't matter, it works anyway. I'd like to also let you know that I have Tigo on each of the panels. I don't know if I showed you the panels earlier. So I have, yeah, I did show you the panel where I was calculating, the SOC values. So I have Tigo optimizer. So the Tigo optimizer, what it does is it will optimally use the MPPT technology, which it draws like it's a sucker, it's like a vampire of energy, like it sucks from the panel how much the maximum potential that the panel can provide, and it also regulates and it also isolates. So if one panel is down, for example, the current will bypass that panel and come through this and come through. But if there was no Tigo, if that panel goes down, the whole parallel connection is gone. So that's one of the reasons why I had to put Tigo in each of the panels. So, and also you can also monitor and see which panel is doing good and which panel is not doing good, as you can see from this. And you have this is the energy that it has produced. One panel has produced, this panel has produced since today. Altogether, this is the energy that they've produced: 1,000, just over 1,000 kilowatts, 1,200 250 kilowatts. Like I said, it's not a sunny day. On a really good day, you can get 5 kilowatt, even 10 kilowatt per string. So this is one string, this is another string. So this is string 1, string 2. So each of the string can go up to 10 kilowatt each. And you can also see what the power. I'm not sure it's going to show anything now because there's not a lot of energy today, but usually if I step back when it was a sunny day, usually you can also see the power, that each of the panel, the active current power that the panel is generating. So yeah, as you can see, like tell you 60 watt at the moment, 44 watt at the moment, so yeah. And yeah, it gives you the monitoring capability. So yeah, so that's basically it. So I'd like to show you also I used to be with Eon, and Eon was charging me 32 pence per kilowatt and per kilowatt hour. So I moved to Octopus. My colleague advised me to move to Octopus, and I moved to Octopus. And you can see Octopus, you can get 16, that's half of that, kilowatt per second. So sometimes you get 9, look, you see 9. Sometimes you get even 1p, and sometimes I've seen 0 and even minus. So what I do is I charge when it's at the lowest, and let it discharge when the hours to avoid is between 4 o'clock, so 1600 to 1900. So you avoid those hours. So what I've actually done is I charge for an hour between 1500 and 1545. So for 45 minutes I charge, just in case if there was no sun. I don't want to be going in there and setting the values all the time every day. So I just did that, so it just stays permanently. So in case if there's no sun, it charges for 45 minutes, and then that 45 minutes should be able to make it jump this period. So I will never use electricity at that value, at that price. Yeah, so if there's sun, still no problem. If there's sun, then it still charges the battery, but it will be charging the battery with the solar. But if there's no sun, it will be charging it with the grid, but at that price. Smart, right? So yeah, so that's basically it. I didn't want to make this video too long. I don't know what else do you want me to talk about here. Maybe these pictures can remind me of okay, there's a GPIO, the GPIO that we talked about. Okay, this is not ESP, this is another project. So there's a GPIO pins. You can see, this is when I was doing my experiment. So the GPIO pin, so these are the GPIO pin. So if you get one of these board, the ESP32 dev board, these are the pin outs. So you can see the 16 and the 17 pin is there, and the 32 pin should be somewhere around 32 and 33. So you can see the 32 and is it 20, no, not 22, 23 and 20, sorry, 22 and 23 pin should be here. Yeah, so the serial connection is TX-RX. You can see it there, and then you can also see this is the reason why I tried the 01 and 03, because it's got TX and RX serial pin outs there as well. So those are the pins, and yeah, basically using the UART system. I'm not sure what else. I don't know if I tell you about how I changed the battery. I can't remember now how I changed the So this is the technology that I'm going to use next. So this is a new technology. So this is got the ESP32S free and the CAN, so it plugs into each other, and it's just one unit, and you just program it. And if you're using if you are using Bluetooth, you don't even need this wire. So you just have the Bluetooth, you just have this module stuck somewhere, and the CAN H CAN L wire coming from here to the inverter, basically. So I'm still working on that project. So this is the project, the project I'm working on for the second string. I have removed the original, like I did with the first, the power BMS. I removed the original BMS of the Growatt battery, and I've replaced it with JK. This BMS is a little different from the other BMS that I was showing you earlier. This BMS is an inverter BMS. They both have the protocols, the Polytech protocol, the SMA protocol, the surplus protocol, whatever protocol. Yeah, they have the protocols which we require, but the difference is that this is an inverter BMS. So I'm hoping to have I'm done with this, and I have another battery to convert, and then I'll connect them in parallel and hopefully be able to use them without the ESP technology. I'll do a separate video on that. This is almost when that's the finishing work, and then I closed it off. Again, you label the cells. It's a 14 cells for me. So yeah, this is inside the BMS, on the settings. That is the BMS settings on the firmware. So you can go in there and put the values. I will do a separate video on this. This is there's quite a lot in here as well. It's not difficult, but it's quite a lot in here as well. These are the protocols, for the UART protocol that has been programmed into the BMS, basically. So yeah, I think the video is long enough. Don't want to bore you with more and more stuff, but I think my second string I'm working on is going to be a sofa. It's going to be a sofa. It's a sofa inverter. It's not working at the moment, so it's on warranty. So I've asked them to come and collect it. When they bring it back, then I'll connect that sofa inverter to the BMS, to the battery that I'm converting, to the inverter BMS battery that I'm converting, basically. So yeah, so I think I took you down the memory lanes, and how I got here, and yeah, so that's basically this is basically when I was just before I put in the BMS. So that's the battery, so that's the BMS. I would do a separate video on this warranted a separate video, if you request it in the comments section. So yeah, so that's basically it. So that is my solar project, and I hope that it was informative. If I know there's going to be a lot of questions, leave something in the comment, and I will endeavor to answer your questions as much as I can. And that's it. Chaos Nature out.